9.6 example 2, we're going to solve nonlinear systems algebraically. For the first one, we're going to solve using substitution. So I wrote down some notes here. You might want to pause the video and copy down these notes so you can refer back to them. But when we solve by substitution, it's the same steps as we did back in chapter 5. So first, we need to have at least one equation equal to one of the variables, and most of the time they already will be, so you don't have to worry about that too much, but you just need one. Second, we're going to substitute the expression that's equal to the variable into the other equation, and then we'll solve. When we solve, it's going to give us an answer for one of the variables. But don't forget, our answers are always in ordered pair, x and y. So after I find this first variable, I need to plug that answer into one of the equations and find the other variable. We're always going to write our solution or solutions as ordered pair or ordered pairs. It is possible to get no solution, one solution, and two solutions. So be ready for that. Let's take a look at example 2. We're going to go through this example together. I'm just getting it right from the book. I already wrote the equations down here. Y equals x squared plus x minus 1, and y equals negative 2x plus 3. So both of these equations are actually equal to y, which is fine. I'm going to take this first equation and I'm going to substitute it into the second equation in for y. Since this is what y equals, let's plug this in for y. So when I plug this in for y, now my equation is going to be x squared plus x minus 1 equals negative 2x plus 3. All right, so we can see here now this is a quadratic equation because it has an x squared in it. So I need to figure out how am I going to solve this quadratic equation. I think my first step is to get the equation equal to 0 so I can see what it looks like in standard form. So let's do that. I'm going to add 2x to both sides. And in the same step, let's also minus 3 from both sides. So then I can make this one side equal to 0. So now my equation is going to be x squared plus 3x minus 4 equals 0. Now this is a quadratic equation. We're going to solve this. So think back to what we did in section 9.5 and let's figure out the best method to solve this. Since that's in the form x squared plus bx plus c equals 0, the first thing I'm going to try is factoring. Let's see if we can factor this expression. I think that would be the best way to go about doing it. So our product in this equation is the c, that's our negative 4, and our sum in this equation is our b, which is 3. Let's find our numbers. What times what is negative 4 and adds up to 3? That would be 4 times negative 1. 4 plus negative 1. And I already found my two numbers. All right, so let's factor this equation here. I'm going to set up my two parentheses, equals 0. Break up the x squared to be x and x. Fill in your numbers, positive 4, so plus 4, negative 1, so minus 1, and my expression is factored. Remember, I need to solve now, so let's solve for x. I'm going to set each one of these equal to 0. X plus 4 equals 0, and x minus 1 equals 0. Let's get our two x's. So x equals negative 4, and x equals positive 1. Now we're not done yet. Remember, our answer has to be an ordered pair, x and y. Since I have two x's, I need to find two y's, which means I'm going to have two solutions. So we're going to take one at a time. We're going to plug one of them into one of the equations, it doesn't matter, and find what y equals. I'm going to use this linear equation because it's a lot easier to plug numbers in than the quadratic, but technically it doesn't matter which one you plug it into. So let's plug in x equals negative 4 into this linear equation. Let's find the y. So it's going to be y equals negative 2 times negative 4 plus 3. We get positive 8 plus 3 is 11. So there we have our first solution is the ordered pair negative 4, 11. Let's do our second x. where x is 1. Again, I'm going to plug it into the same exact equation. I could do the quadratic, but it doesn't matter. It should give me the same answer. Y equals negative 2 times 1 plus 3. So that's negative 2 plus 3, which equals 1. Let's write it as an ordered pair. 1, 1. And that is our second solution. We have two solutions to this problem, negative 4, 11, and 1, 1. A good way to check is I could use my graphing calculator and do what I did last lesson when we were solving by graphing, or I could take this point, plug it into both equations, make sure it works, and then take this point and plug it into both equations and make sure that it works. And that's totally up to you. I'm gonna use my graphing calculator because I think that's faster. So let's go to y equals. Let's type this in. We have x squared plus x minus 1 and negative 2x plus 3. Let's hit graph. Okay, so we have 2 points of intersection. One is up here, that's the negative 4, 11 just off the screen. And then this one over here, which is the 1, 1. Let's use our calculator and let's just double check. Second calc, intersect. And it's gonna give me this one first because the cursor's closer to it. So hit enter, enter, enter. And there it is, our point 1, 1. So I know I got that one right. Let's find the other point up here at the top. Second calc, intersect. And remember, I have to move the cursor closer to that point, otherwise it'll just give me the same answer. So now my cursor is up here, closer to this point of intersection. Now do enter, enter, enter. And there it is, negative 4, 11. So I got this answer correct. Let's do another example like this, and I'm gonna get this problem from monitoring progress number 4. This is just on the next page here. Let me write down the equation so that we can see what we're working with. Monitoring progress 4 is right up here. We have y equals x squared plus 9, and then y equals 9. Okay, again, we're gonna solve by substitution. So we have both equations equal to y. It doesn't matter which one you plug in. I could plug the first one into the second one or the second one into the first one. It doesn't matter. Let's do the second one into the first one this time, just so that we can change it up a bit, but it doesn't matter. So now our equation is gonna be 9 equals x squared plus 9. Let's solve this equation for x. So let's think about what the best way to solve this one is. Since this is a quadratic equation, let's choose the best method. The first thing that I notice here is there's no bx term. So since there is no bx term, I'm gonna use square roots. Square roots is definitely the best way to go about solving this if there's no bx term. Let's isolate the x squared. We're gonna subtract 9 from both sides. So 0 equals x squared. Let's use square roots. So we're gonna take the square root of both sides, and I get x equals 0. Remember, the square root of 0 is just 0. Normally, if this was a positive number, remember it would be plus or minus that number, but there is no such thing as positive and negative 0. Okay, we're not done yet. This is our x, but I still need to find our y. There's only one x here, so that means there's only gonna be one solution this time. Let's take our x and let's plug it in. And it doesn't matter which equation you plug it into, but let's think about this second equation right here. This second equation doesn't even have an x. It says y is 9. I don't even need to plug the x in to find it because the y is 9. It's always gonna be 9. If you're not sure, you can always plug in x equals 0 into the first equation if you want, but you're gonna see what's gonna happen here. Y equals 0 squared plus 9. You just get y equals 9. So you actually didn't even have to do that. You could have just said y equals 9. Let's write it as an ordered pair. So our one solution for this is 0, 9.